Hello folks, today I'm going to solve some examples related to test for divergence. And namely we just said TD, or you can just write divergence test, that's the same. And the idea is this: if the limit of an is not 0, then we just say the corresponding series sum of an is divergent. That's what it says. And here's a one small warning. If limit of an is 0, then we have no conclusion. So in that case, just be careful. Like if you take the limit of an, if you get 0, you can't use test for divergence, as you see. Like the best example is just a harmonic series. You look at the limit of 1 over n, which is just namely 0, but the sum of 1 over n is divergent. So the limit might be 0, you can get something divergent. Or just for example, if you take limit of 1 over n squared, this is again 0, and sum of 1 over n squared is convergent. There's a p series with p equals 2, so you see it's just convergent. So we have no conclusion. It might be divergent, convergent. You have to apply some of the test or some of the method. So let's just solve some examples related to test for divergence. I mean, just the first example, I can just say, look at this one. Sum and start from 1 up to infinity. Let's say you have 3n to the 4 plus n squared minus 10 divided by 2n to the 4 plus 7n plus 8, for example. If you look at this one, I mean, you can see it's not, of course, like a geometric series, and the degree of the top is just 4. Okay, and if you look at the degree of the bottom, it's again 4. So really, you can expect the limit of this one to be 3 halves. I mean, if you really go to the largest powers of n, just see that's 3 into the 4 over 2 into the 4, so it will be 3 over 2. I mean, you can just see that clearly. Proving that one is so easy. Limit of an, we have limit of 3n to the 4 plus n squared minus 10 divided by 2n to the 4 plus 7n plus 8. So let's divide top and bottom by n to the 4. So that's the largest power of n. You divide the top and the bottom by n to the 4 and see what happens. So if we divide by n to the 4, we're going to get limit, and you see that will be 3 plus, it will be n squared over n to the 4. We have minus 10 over n to the 4. Over here we have 2 plus 7n over n to the 4 minus 8 over n to the 4. So, and then if you really simplify, you can just see that will be a limit. We have 3 plus 1 over n squared minus 10 over n to the 4. See this n to the 4 n squared, that will be 1 over n squared. Then we have 2 plus 7 over n cubed, the minus 8 over n to the 4. So that's what we get. And then if you look at like this part, this one, 1 over n squared, 10 over n to the 4, 7 over n cubed, 8 over n to the 4, all these really goes to 0 as n goes to infinity. Of course, just don't forget here, we don't write it down, but we just mean the limit at infinity. So the limit is just, you can see limit of an is just 3 halves. which is not 0. Just please be careful with this. The sequence is convergent, but we're talking about the series. So by test for divergence, this series is divergent. So that's what we have. You can see it's so clear. You can just see the limit is not 0. That implies that the series is divergent. Another common example that I want to solve, of course the problem is just determine whether this is convergent or divergent. But look at this one, limit n starts from 1 up to infinity. Let's say the nth root of 4. So basically you're talking about this. 4 plus square root of 4 plus cube root of 4 plus and so on. So you're taking all the roots of 4. And you can see it's not geometric. And you can write this one as 4 to the 1 over n. It's really something straight. And if you look at the limit of 4 to the 1 over n, of course we know n goes to infinity. Now look at this. 1 over n goes to, I don't want to write it down, but it goes like 1 over, I'm going to write it down, but it's not like a good notation. 1 over infinity, which really, you can see the denominator becomes larger, so that it really goes to 0. So the answer to this limit will be 4 to the 0. And you know 4 to the 0 is what? 1, which is not 0. So again, by test for divergence, this series is divergent. So this is another great example, and maybe I was just starting to this one, but I can just give you this one as another example. It might be something interesting. When this one really includes ln, you can just see ln of n squared plus 4 over 3n squared plus 10. And it's not geometric. Once you take the limit of an, this limit of n squared plus 4 over, you can just see 3n squared plus 10. Yeah, I started to solve this one, but I couldn't finish, so let's just finish here. So you see, I mean, by the same way, like you can really look at the limit of this inner part, and you can divide by n squared. So really, if I have limit of n squared plus 4, by the same argument we solved in the first example, so 3n squared plus 10, you can divide both sides by n squared. So basically you're multiplying by 1 over n squared. So if you do this, you'll see the limit will be, when I have 1 plus 4 over n squared, at the bottom I have 3 plus 10 over n squared. And you see this one goes to 0 and that one goes to 0. So mainly this limit will be 1 over 3. Of course, which is not 0. And again, just by test for divergence, this series is divergent. So you see, it's not really that hard. You can just try like different examples, and maybe just I can just give you one last example. Just the last one. It's really so straight, simple. Look at this one, another example. Sum of n starts from 1 up to infinity. We have e to the n divided by n squared plus 5. Something like this. This is another interesting one. So you see, if you take like, you really need to take the limit of e to the n over n squared plus 5. But here's the way how you use the L'Hopital's rule. Look at this. So I can really take the limit of this one, limit of the function e to the x divided by x squared plus 5 as x goes to infinity. So you see, like, this is of type infinity over infinity. So I apply the L'Hopital's rule, and that will be limit x goes to infinity. The derivative of the top is just itself, and derivative of the bottom is just 2x. So you see this is again of type infinity over infinity. So I can apply LR again. Now it will be limit x goes to infinity e to the x over 2. And you can see definitely this goes to infinity, which is not 0. So basically, if you go back to here, since this is infinity, that will just go to infinity. And then that means this is not 0, an. So again, we can just say this series is divergent by test for divergence. So this is another good example. I mean, I just try to give you 4 examples. That will be, I think, good enough. And thanks for watching, and bye.